Have you ever wondered what's really inside the digital toolbox of the folks who keep our online world safe? Well, today we're going to take a peek. We're going on a tour of the powerful, super fascinating, and sometimes intimidating tools used every single day by cybersecurity professionals. So let's dive right in. All right, let me start with a question for you. When you think of a search engine, you're probably thinking of Google, right? You type something in and you get back websites, articles, maybe some videos. But what if you could search for things instead? And I mean actual physical devices connected to the internet all around us. Well, it turns out you can. Meet Shodan. This thing is wild. It doesn't crawl web pages, it crawls the internet itself, sniffing out devices. We're talking servers, routers, webcams, industrial control systems, you name it. Basically anything that's connected and publicly accessible. They call it the search engine for the Internet of Everything, and you would not believe some of the things it has found, like totally unsecured medical devices and even power plant controls, just out there for anyone who knows how to look. And the level of details Shodan finds is just astounding. It's not just about finding a webcam, it's about identifying the exact software it's running and which of its ports are open. Now, think of ports like digital doors on a building. Port 80 is for website traffic, port 22 is for secure login. Shodan literally shows you which of those doors are unlocked. For a security team, this info is pure gold. It lets them see their own company from an attacker's point of view. And, it often reveals exposed devices they never even knew were online. Okay, so finding devices is one thing, but a massive part of cybersecurity is gathering intelligence before anything bad happens. And that brings us to our next stop, the world of digital detective work, better known as OSINT. OSINT, or Open Source Intelligence, sounds really complex, but the idea behind it is actually pretty simple. It's the art of finding and connecting all these little pieces of information that are already out there in public, on social media, websites, public records, and weaving them together to build a much bigger picture. It's all about turning that scattered data into something meaningful, something you can act on. And this right here is a perfect illustration of one of the top tools for OSINT, Maltego. Look, if OSINT is detective work, then Maltego is that digital corkboard you see in movies, with all the photos and red strings connecting everything. You feed it one little piece of information, like an email address or domain name, and it automatically maps out all the known public connections, creating these incredible visual webs of relationships. It literally connects the dots for you. Now, not all OSINT tools are that visual. In fact, some of the most powerful ones are just plain text on a screen. On the left, you've got the harvester. Think of that as your quick first pass, designed to harvest the easy-to-find stuff like employee emails and company subdomains. But on the right, you have Recon-ng. That's a full-on investigation framework. It's like a modular Swiss Army knife that lets an analyst dig way, way deeper, using that initial data to build out a complete intelligence profile. And here's what they actually look like in action. See? No fancy buttons, no slick graphics, just a blinking cursor and a whole lot of power. Over on the left, you can see the harvester's output, showing you its search options. And on the right is the Recon-ng console, just waiting for an analyst to load up specific modules for their investigation. This is the real deal. It's where security pros often work, typing in precise commands to methodically gather intelligence, one piece at a time. That manual, piece-by-piece process is incredibly thorough, but man, it can be time-consuming. Which, leads to a pretty natural question. What if you could just automate that whole digital detective process? And that is exactly what SpiderFoot does. It's an OSINT automation tool. You give it a single target, say a domain name or an IP address, and it just goes to work, automatically pinging hundreds of different public data sources, pulling in everything it can possibly find, and then organizing it all for you. It's kind of like having a whole team of junior investigators working for you 24/7. So far, we've been gathering intelligence pretty passively, from the outside looking in. But what happens when security professionals need to actively test a system's defenses? Well, this is where we shift from investigation to what's known as ethical hacking or penetration testing. And the undisputed king in this arena is a tool called Metasploit. If the other tools help you find the doors and windows on a building, Metasploit is the framework that gives you a massive set of keys to see if any of them are unlocked. It's a huge database of known vulnerabilities and the code needed to test them, letting security testers simulate real-world attacks, but in a totally controlled environment. All right, before we go any further, we really need to pause for a second. Because when you're talking about a tool this powerful, there is an absolutely critical point that cannot be overlooked. And here it is. This is the crucial part. Tools like Metasploit are for professionals who have explicit legal permission to test a system, period. Using them without authorization isn't just a bad idea, it's illegal and it has some very serious consequences. This is the bright shining line between an ethical hacker and a criminal. It's all about securing systems, not breaking into them. This is the Metasploit console. It's right here that an ethical hacker, with full permission from a company, will test to see if a security patch actually worked, or if that company's defenses can hold up against a specific type of attack. Their job is to find the weaknesses so the organization can fix them before a real attacker does. Now, this whole idea of accessing a computer from far away isn't just for ethical hackers. The same basic technology powers something many of us use all the time, which brings us to a much more familiar part of the digital toolbox: remote IT support. I'm sure you've probably seen or maybe even used some of these before. Tools like Windows Remote Desktop, TeamViewer, or Apple Screen Sharing, they're all built on the exact same principle of remote access. They're just designed for a very different and very helpful purpose. So instead of testing for vulnerabilities, these tools are used to fix problems. They let your company's IT support team see what's on your screen, install that piece of software you need, or figure out why your printer just won't work, all without ever having to leave their desk. It's really the friendly face of remote access technology. So as we start to wrap up our tour here, let's kind of zoom out and put all these pieces together. We've seen tools for discovery, for intelligence gathering, for ethical hacking, and even for everyday help desk support. You see, each of these tools has a really critical role to play in our whole digital world, from defending huge corporate networks and gathering threat intelligence, to actively testing for weaknesses and responding when something goes wrong, all the way to just helping someone with a simple computer problem. Together, they form this complete spectrum of digital interaction. And that brings us right back to the most important takeaway of all. The one thread connecting every single one of these tools isn't the code or the interface, it's the person using it. When they're wielded responsibly, legally, and ethically, this toolbox is exactly what helps make our digital world a safer, more functional, and more reliable place for every single one of us. Which leaves us with one last thought to chew on. A lot of these incredibly powerful tools are open source and they're really easy to access. So in a world where the tools of the defender and the attacker are often the very same, who's ultimately responsible for security? Is it the big companies, the software developers, or does a piece of that responsibility now fall on all of us?